So in this first lesson in our statistical analysis unit, a lot of this will hopefully sound pretty familiar, stuff that you did back in Algebra 1. So we're going to talk about measures of center and graphical representations. So these measures of center you've probably heard of before. We're dealing with mean, median, and mode. So these are different ways to talk about a central measure of your data. So if remember, mean is average, mean is that middle number, and mode is the number that repeats the most. And sometimes that could be more than one number, and sometimes you can have no mode. So you want to remember those bits and pieces from algebra. But anyway, it might help to, of course, first organize your data. So you might want to write from lowest number to highest number, and of course, everything sequentially. So you'll see we have 2 zeros, then a 1, 2 2s, a 3, and a 4. So I'm just going to go ahead and reorder my data. And then that makes it much easier to do a couple of things. So we can find median pretty quickly, and we can also visually see the mode. So just remember, again, right, what do those three things mean? Mean is the average, mean is the middle value, and mode is the most frequent value. Okay, so let's take a look at our actual data, and let's talk about these three measures of center. So how do we find the mean? Well, the mean is, like I said, the average. So when you do the mean, you take the sum of your values and you divide it by the total number of values you have. So in this case, we're going to add up 0 plus 0 plus 1 plus 2 plus 2 plus 3 plus 4, and then divide it by the total number of values we have, which is 1, 2, 3, 4, 5, 6, 7. Okay, and then that will give us 12/7, which is approximately 1.714. Okay, so I just rounded that to the nearest thousandths, even though it didn't specify. But remember, if you're not sure, you can always ask what the rounding should be, but hopefully we'll remember to put that on your assignments. Okay, so then what about median? So remember, with median, we're looking for the central, I wrote mean again. We're looking for the center value, or what that middle number is going to be. So what I'd like to do is sometimes I'll just list out my data again, and then I just kind of count toward the middle. So let me rewrite this. It's really crucial for median to be in numerical order because we want what's in the middle. So if everything's out of order, we're going to get the wrong middle value. So what we can do is we can just count inward. So that's 1, 1, 2, 2, 3, 3, and then 4. We see that middle value is 2 because 2 splits the data completely in half. We have 3 to the right, 3 to the left. So 2 is our median value. Okay. Then our last one is the mode, which again could be multiple values, it could be no value. It all depends on how much repeats. So if we just look back at our data, we can see, okay, well, 0 repeats itself twice, right? And so does 2. So we have 2 modes, which are 0 and 2. And there's mean, median, mode, which hopefully sounds pretty familiar. Okay. So moving on, we can now talk about how we can represent our data. So this next example is talking about a dot plot. So a dot plot sounds probably very familiar as well, but it tells us exactly what we want. We want to plot dots on a number line. So here we want to be very careful because with stats, we usually have specific data sets we're working with. So we want to make sure we do label everything. So if you look at this, we are going to be looking at the number of hours people exercise in a 7-day period. So each of these values represent the number of hours of exercise. So we want to make sure we label our number line. Now we've given meaning to our visual because that's what we want our visuals to do. We want it to actually depict some information. And then what we're basically going to do is make a number line to represent all of these numbers and then put a dot every time we see it. So what I like to do is I like to look for my smallest number, and then I like to look for my biggest number, and that tells me kind of how big or how spread out I want my number line to be. So you can see my smallest number is 2. My largest number looks like it's 13. So I just want to make sure I can fit from 2 to 13 on there. Remember, everything has to be evenly spaced on our number line. So I'm going to try to fit, let's say, 0 to 14 on here. All right, so there's my number line. And again, the key thing is to make sure you can fit your minimum and maximum values on there, and as well as pick a scale that'll work, and then make sure it's all evenly spaced out. And then here's the easy part, right? We just take a look at each number and just put a dot where we have to represent how many of each value we have. So let's see, my first number is an 8. So I'm going to put a dot right there above the 8. And I like to cross off as I go so I don't put the same thing twice. So then there's a 2, right? And then we've got a 4. And then I've got a 7.5, which is right halfway between 7 and 8. So there's my 7.5, right? There's 10, and then 11, and 5, and 6, and you get the idea. And as soon as you have one repeat, so see how 8 repeats? We're just going to put another dot right above 8, so we'll stack it. All right, so I'm just going to go ahead and finish this off and show you the finished product. If you want to pause and finish it yourself and check, feel free to pause right now. And there you have it. That's my completed dot plot. What you want to make sure you do is, to the best of your ability, because I know we're kind of freehanding this, is if we have only one of each value, they're kind of on that same horizontal, and then we have 2, we're lining it up. So that way it's really nice and neat, because with these visuals, we want to make sure whoever's reading it, right, your audience, will be able to see the data and see what we're trying to say really easily. Okay, next up we have our scatter plot. So scatter plots, basically the same thing we've done before with plotting X and Y, but remember, because we're dealing with stats, we're comparing 2 different sets of data. We want to make sure we actually represent that data on our axes. So if we say X is time and Y is the depth, we want to go ahead and label that. So X is time in minutes. Oops, and I can write that a little bit neater. So we're going to have time in minutes. And then we can see our lowest value is 2, our highest value is 22, and we want to somehow make sure we fit it all in to this graph. So if I want to start at 0, I might want to go ahead and count by 2s, so that way I can fit 2 to 22 on here. So I'm just going to go ahead and label every other so it's a little bit easier to read, but you can see I'm going 0, 2, 4, 6, 8, and so on. So I just finished labeling that off. And then if we look at our Y value, we're looking at depth of this bathtub, of the water in the bathtub, in centimeters. So again, we want to label our axes. So this is depth in centimeters. And then again, if you look at our minimum value is 7, our largest value is 47, we want to make sure we can fit it in. So remember, your scale for your X and Y don't have to go the same. So here I might decide to go by 4s to make sure I can get from 7 to 47 on here. So again, I'm going to write every other because I write pretty messily, but you can see I'm going 0, 4, 8, then 12, 16, and so on. So I'll just finish labeling these off. There we go. So now we are all set up to actually plot our points. So remember, the labeling is super important, and picking a good scale, right, for each axis, and they could be different. Like the X, like I have here, is going by 2s, and my Y is going by 4s. So pick whatever will work to make everything fit, but also don't make it so small so everything's scattered or everything's clustered in one tiny part, because again, think about your audience and your readers. You want to make sure your visuals are nice and easy to read. So here we're just going to treat time as X, depth as Y, and just plot your points. So I'm going to go ahead and plot 2, 7, which is not going to be exact because I have to kind of guesstimate where 7 is going to be, and that's okay, right? We want to be as accurate as possible, and I might want to make that a little bit smaller to be closer to 8, which is 7. There we go, right? And then I'll have 4, 8, which is actually a good point for me to plot here. And then 6, 13. And you guys get the idea. So again, like before, if you want to pause, finish this yourself, and then check when you're done. Go for it. I'm going to go ahead and finish plotting and be right back. And there you go. There is my completed scatter plot. So hopefully pretty straightforward there. All right, moving on. So next up we have a bar graph, and then if you look below, we also have a histogram. So these two actually look very similar because we're going to graph bars, but two very different graphical representations, because this bar graph is used for what we call qualitative data. So if you remember this from Algebra 1, this is stuff like descriptions, right? Like the color of your eyes or the type of fruit in a bowl. So that's qualitative data. So we're going to basically make bars to represent each category, and then we'll show how many of each category are there. So what's really important here is that with the bar graph, our bars do not touch. Okay, so for a bar graph, our bars don't touch, and then just like before, we've got two axes. We want to say what this is representing. So we're going to put the fruit on the X, the number of students on the Y, and then we'll go from there. Oops, moving my paper around. All right, so I went ahead and labeled my axes, and then the number of students, hopefully pretty straightforward, right? We're going lowest value 12, highest value 35, so you just want to figure out how to fit that onto your y-axis. But then you might be wondering, wait, Miss Wong, we've got apple, banana, grape, orange, pear. How the heck do we put this on our x-axis? Well, because these are just categories, these are labels, what you want to do is basically pick the width of each bar. So we want to make sure we can fit 1, 2, 3, 4, 5 bars here without making them touch, and just label each bar apple, banana, grape, orange, and pear. So I might say, let's skip that first column of boxes and let's let the second one be apple. So apple's going to go from here to here. Skip one, and then from here to here is going to be banana. Skip another, and then the next one's going to be grape, and so on. All right, so I just went ahead and finished labeling everything, and you'll see I also did my y-axis, and I decided to go by 3s, just labeling every other for the sake of clarity. And then all we need to do now is create our bars. So my first bar, apple, goes up to 35. So I'm going to go ahead and find approximately 35. So that's 33, 34, 35 will be close to 36. Obviously, if you have a straight edge, you want to go ahead and use that straight edge. I'm kind of freehanding this because I am drawing on my tablet, so it's going to be pretty darn ugly. But again, hopefully you guys are being a little bit more neat, and you can go ahead and use a straight edge. So there's my first bar. Remember, the key thing about our bar graph is the bars don't touch, so banana is going to be the next one over, but I'm skipping a space. So banana is going to go all the way up to 40, which is roughly here. And there you go. So then you can go ahead and fill in the rest of these bars. So if you want to try that yourself, go ahead and pause while I finish this off, and I'll be right back. And there we go. So there's a bar graph. So again, that's used for qualitative data, which are categories, right? So not numerical data. We're just basically counting how many apples, how many people with blue eyes, how many people are left-handed, things like that. All right. So now we want to compare that to the next one, which is a histogram. So it's going to look very similar to a bar graph, but this uses what we call quantitative data, which is actually numbers like your mile time, or the amount of money you've earned in a month, or the number of people going in and out of the store. So it's all going to be numbers that we can count. So if you remember this from Algebra 1, there's a little more we have to do than just be able to take our values. So when we're creating a histogram, we're going to basically create 6 to 8 groups or classes, and we're going to kind of tally up our data. So what I like to do to figure out my groups is, again, we're aiming for 6 to 8 groups. So we want to create intervals. So I would look for my smallest value, which is 5, and then my highest value, which looks like it's going to be 140. And then I just kind of do 140 minus 5, which is 135, and divide that by 6. That gets me about 22.5, which isn't a really nice number. So I might say let's do intervals of basically 25, and that way I can create about 6 groups. So then each interval has to be the same width, and we usually only include the end of the interval. So that means we usually only include one end of the interval, so we'd include either the first number or the last number, but not both. So you can write this as like an interval with, 0 to 2, or you can use an inequality. And I like the inequalities a little bit better because it makes it clearer, so I'll show you both. Okay, so I kind of wrote those notes down here for you to reference. So like I was saying, let's pick kind of a nice interval to work with. So I said 25 seems to be a good range because I did that maximum value minus the minimum value divided by the number of bars I was hoping for, and I got 22.5, and I'm like, okay, let's go to 25 and see what we can do. So what we want to do is we want to go ahead and kind of create a little table to tally up how many values go in each interval. So let me show you what I mean. Let me set up my table. Okay, so there's how I set up my table. So we're going to create our intervals that represent the check amounts, and then we're going to kind of tally up how many from our raw data go in each group, and then we'll just total up the number of checks for each group. So like I was saying, I'm going to go 0 to 25, then 25 to 50, so I'm going to go by 25. So you could totally do this and write 0 to 25, but like I was saying before, we only include one end of the interval, so you have to decide, okay, I'm only going to include 0 here, and not 25, or I'm going to not include 0 and I'm going to include 25. And then for the sake of clarity, I actually would prefer to just write in inequality. So let's say our check amount is X, so I can say 0 is less than or equal to X, which is less than 25. And then it's really clear, okay, I'm including 0 but not 25. So then my next group, my next interval will be 25 is less than or equal to X, which is less than 50. Sorry, my hand's doing weird things. And then we want to keep going until we can, we don't want any groups of 0 at the beginning or the end. So we want to make sure we just stop once we include our highest value, which is 140. So let me go ahead and finish off these intervals. And there we go. So you can see I have 1, 2, 3, 4, 5, 6 intervals, 6 groups, which will give me 6 bars. And remember, in general, we're aiming for 6 to 8. So this is looking great. So now we're going to go ahead and tally. So what I'm going to do is basically decide, or not decide, but just kind of look at the raw data and see what numbers kind of fall in which group. And then we're just going to total that up. So like you can see, 65 is between 50 and 75. That's a tally right there. 40 is between 25 and 50. 10 is 0 to 25. 100, I'm not including here because 100 is not included in that group from 70 to 75 to 100. I'm going to include in the next one because that's where my less than or equal to is. So be careful with that, right? Same with 75. We don't include it here. We include it in this next group where it's 75 is less than or equal to X is less than 100. Then we have another 75, so we just put another tally there. And you can see I'm crossing them off as I go because I don't want to count something twice because it's really, really crucial that we have accurate data in our graphs. So I'm going to go ahead and finish these tallies. If you want to pause right now and do your own tallies and check when we come back, go for it. All right, so I just finished all of my tallies. So then the number of checks per group is just the total number of tallies. So we have 3 total. Ooh, sorry, my hand's moving the document. So 3 here, then 5, 6, 7, 8, 9, 8, 5, 1, and 2. So what we're actually going to graph is we're going to graph what I have here in blue. We have our interval, which becomes the width of the bar, and the number of checks, which is the height of the bar. So this is your X, this is your Y. All right, so I'm going to go ahead and set up my axes. Remember, of course, start by labeling what your axes represents. So this is my check amounts. And that's in dollars. And then we have the total number of checks, right? So that goes along the Y. That's your frequency. And then we just have to figure out, okay, well, how do I want to space this out? So my check amounts go from 0 to 150, so I want to make sure that goes on the X. And then my number of checks needs to go from 0 to 9 on the Y. So I'm going to go ahead and put in my scales. All right, there you go. So you can see I went by 20, not 25, 12.5 on the X. But it's kind of nice to use the intervals that you've created. So I'm going to use like 0 to 25, 25 to 50. And remember, evenly spaced, because those are our bars. And then I went by ones on the Y just so I can fit the frequency in. Now, before I start doing this, make sure you see how each of these intervals, right? I go from 0 to 25 and then I pick up the same number. So that means our bars are actually going to touch. They're not going to be gaps between the bars. And that's the big difference between the histogram and the bar chart. So we are going to have our bars touch. Right? And then you can remember this because we're using quantitative data. for the histogram. Sorry for the messy handwriting. Okay, so let's go ahead and draw in our bars. So from 0 to 25, there's a total of 3. So I'm going to find 3 here, go across, there's 0 to 25, there's my first bar. Then from 25 to 50, there's 9. So I'm just going to bring that vertical line up to hit 9. And then go across and stop at 50. Right, so you can see all my bars are touching because we don't have gaps in our intervals, so we want them to be continuous. So you can go ahead and finish the rest of these bars while I finish mine and come back and check. And if you want to pause right now, go ahead and pause. So there's my completed histogram. So it's really kind of wonky because I'm not using the straight edge because I'm freehanding it, but definitely feel free to use the straight edge just to make it a little bit neater. I would totally do that if I wasn't working on my tablet. All right, cool. So that is the histogram. And let's take a look at the next page because we've got one last plot to talk about, which is probably something you also remember, our box and whisker plot. All right, so if you remember, your box and whisker plot is literally a box with 2 whiskers, right, on either end. And what's cool about this representation, it also shows you how spread out our data is. So that's kind of neat. What we do is we need to calculate what's called our 5-number summary, if you remember that. So these are the 5 key numbers that create our box and whisker, our box and our whiskers. So we have our minimum value, which is the lowest value, quartile 1, the median, quartile 3, and then the maximum. If you remember, quartiles are basically a quarter. So we want to know, where that first quarter would be, then that median, which is 50%, and then Q3, which would be our 75% mark, and our maximum, which is the highest value. We can also calculate the spread. So 2 different spreads. We have an interquartile range, which is quartile 3 minus quartile 1. And then we have our total range, which is maximum minus minimum. Okay, so if we're going to create our box and whisker plot for this data, we want to figure out our 5-number summary first. And then we're also going to find the range and the interquartile range from the data. So first off, how do we find the 5-number summary? Well, it's pretty clear, right, what the minimum, the maximum are. So I'm just going to list out my 5-number summary here. And kind of fill in the numbers as I get them. So we want our minimum, Q1, our median, which is the middle, then quartile 3, and then our maximum. So as long as your data is written in numerical order, the minimum, maximum, super straightforward, right? The smallest value is 4, largest value is 10. Awesome. That's the endpoints of our whiskers. So now the question, sorry about that. Now the question is, what about the quartiles and all that? Sorry about that. Low battery, just had to plug back in. Okay, so then median, hopefully pretty straightforward. So we did that before. You're basically counting inward. So if I'm counting my median, there's 1, 2, 3, 4, and 5. There's my median, which is 7. I should mention, since we haven't seen it yet, but if you do have 2 numbers in the middle, then your median is the average of the 2. But here, since we have an odd number, median super straightforward, it's just a number in the middle. So then how do we break up quartile 1 and quartile 3? Because we haven't seen that before. So what we do is we basically don't include the median. So we want to look at that first half and that second half and find the middle number of both. And here you're going to notice, wait a minute, we've got an even number. So if you have an even number of data points, what we're going to do is we're going to average the 2 middle numbers to find the median of that set. So let me just write this here on the side. If we're looking for Q1, right, I have this set of data for, oh, sorry, my hand's moving around. 5, 6, and 6. Then you'll notice, wait a minute, if I try to count inwards, there's 1, there's 2, there's nothing in the middle. So we have 2 values in the middle. So what do? We're going to average it. So we're going to average 5 plus 6 divided by 2. So 11 over 2 is 5.5. That is quartile 1. Okay? And you can basically do the exact same thing for quartile 3, right? If you look in this latter half of the data, we have two numbers in the middle, 8 and 9. We're going to average that. So we're going to do 8 plus 9 divided by 2. So that's going to give me 17 over 2, or 8.5. So there's quartile 3. Okay? So then we can go ahead and put this onto our number line. All right. So just like before, we've got a number line. We want to write down what the data means and all that. And here, I didn't tell you what this is, but it could be, shoe size or whatever. So we're just going to write a generic data label just to say, we need to label this. So don't forget to do that. And then figure out what scale you want to do your number line with. So we really just have to go from 4 to 10 and be able to put my 5.5 and 8.5 on there really nicely. So I might just go from 0 to 11 going by 0.5s. And there we go. So I labeled every other again because you can see my handwriting's pretty gross. So it's a little easier to read. And then what we want to do is kind of mimic this. So we'll put a dot for each of our 5 important points from our 5-number summary. So my minimum is 4. Q1 is 5.5. Median is 7. Quartile 3 is 8.5. And maximum is 10. The box will always go from quartile 1 to quartile 3. We're going to go ahead and put a line through the median and then connect the whiskers out to the maximum and the minimum. And there's our box and whisker plot. All right. Then the last thing we have to do is calculate range and IQR. So remember the range, oh my goodness, sorry, I'm moving that around. The range is maximum minus minimum. So 10 minus 4, which is 6. And our interquartile range is always Q3 minus Q1. So 8.5 minus 5.5, which is 3. And we'll talk about this some more later, but what's interesting here is it shows you kind of how wide the spread is. So you can see we have a decent spread from maximum to minimum, but also our 2 quartiles are spread out a good bit too. So we don't really have a lot of data clustered in one section. But again, we'll talk about this a little bit more when we talk about spread. Okay, so that wraps up SA1 in terms of all the material. After this, you'll see a bunch of U-try problems. So if you'd like, go ahead and pause now and try those U-try problems and go ahead and continue when you're ready to check. So I'm going to work out the 3 U-try problems. Is it 3? Well, however many U-try problems we have, and then continue the video when you're ready to check. Okay, so those are the mean, median modes. Hopefully you saw for that first one, it's an even number of values. So to find the median, of course, first reorder it from smallest to biggest, and then you had to average the 2 middles. Okay, remember it's perfectly fine to have no mode. It's perfectly fine to have more than 1 mode. It's also okay to have 1 mode. It all depends on the data. And there's the dot plot and the box and whisker plot. Again, if you use a straight edge, good for you. I'm freehanding this, so it looks a little bit uglier. And remember, for the dot plot, it's perfectly fine to have gaps. Just literally put the data down. And it's kind of neat. You can use the same data for 2 different representations. And that's what stats is kind of fun to think about. You have to think about how you want to represent it so you can show different pieces of information. Okay, next up is the histogram. So with this histogram, you might have something that looks a little different, but make sure, again, you have your axes labeled, and then we need to have 6 intervals because it's a histogram. Our bars are going to touch. Now, this is an interesting situation where I created 6, but I couldn't get them all to fit by using what we normally do, by including the first value and not the second value. So I went ahead and I switched it around, and I said, what if we go 0 is less than x is less than or equal to 20? And you can totally do that. Rule of thumb, we normally include the lower bound, but not the upper bound, but you can always switch it around. There's no steadfast rule that says you must always include the lower number, not the upper number. Okay, so that's how I created my bars for this histogram. And again, yours might be a little bit different because you might have 8 bars, you might have 7 bars, but what's important is you've got your labels, you've got your scale, you've got every data point represented, and your bars are touching. Okay, so that is it for this set of notes. Thanks for listening.